Yes. Good evening, my dear kids. Am I audible?
Good evening, sir.
Good evening. Excellent. Good evening, Kanna.
Good evening.
Good evening, my dear kids. So, in our last class, what we have seen, please check. We tried to understand what is simple harmonic motion. What do you mean by simple harmonic motion? In physics, if acceleration is directly proportional to displacement, and also if acceleration vector is negative of k times y, where k in general in physics we replace with omega square, right? Omega square. This condition is what is called what? Simple harmonic motion. This is physics. If you go to mathematics, what do you mean by simple harmonic motion? If a motion can be described as sin theta cos theta, it may be called as simple harmonic motion. It is as simple as, right? You are right. So, we have in our last class we have clearly proved this, and also we have done, we took in our last class uniform circular motion and we took its shadow on maybe x axis, maybe y axis, whatever is possible as per your wish, and we proved that y is equal to a sin theta, y is equal to a sin omega t. In my last class we took projection on y axis and we called it as y, you may remember, where a is the radius of the circle. We are what we took in our last class. Am I right? Am I right?
Yes.
Yes. And then we found velocity. What is velocity? A omega cos of, come on, omega t is the velocity. We proved that. And also we proved, please check your notebook, omega times square root of a square minus y square. This also we have already proved in our last class. And finally acceleration is equal to minus omega square times y. This also we have proved. Please check that. Please check that. Idellam proof pannirukoma parunga. We have seen graph representing all this, everything we have done it. Please check, my dear kids. If you check yes, and then I can go to next today's topic, I can take you.
Yes, sir.
So, I am moving to today's topic. So, first today I want to introduce you simple pendulum. Let us straight away go to simple pendulum. Come on, simple pendulum.
Sir, you said you'll start with phase.
Phase பண்ணிடலாமா? சிம்பிள் பெண்டலம் முடிச்சிட்டு அப்புறம் ஆரம்பிச்சுக்கலாங்க. குட் பட் அது சிம்பிள் பெண்டலம்னா உங்களுக்கு நல்லா புரியும், அதுக்காக தான். I agree with you. I have to do phase, energy and all those, but once I complete simple pendulum, you will better understand. So, we will do that. You keep reminding me that. Simple pendulum. Simple pendulum. All of you know, you have been learning from since maybe in a very small class like 9th standard or maybe 8th standard, I don't know. You started learning simple pendulum. What do you mean by simple pendulum? A heavy mass suspended by means of thin
Spring.
no, why you want to go to spring? Why you want to go to spring?
I said
String,
string.
sorry Kana. Good. 1 second. I will check if I can get a really simple pendulum bob for you. I will try that if possible. I don't think I have. No, I don't have. Actually, I had one. Okay. It's not right now. It's not there. I don't have right now simple pendulum. I had actually here. I had kept it for you, but today I am not getting it. Okay, fine. A heavy bob suspended by means of a thin thread. Okay, like this. You have seen this. You must have, by this time you must have completed your practicals even on simple pendulum. Am I right? Yes, simple pendulum. So, how shall we start writing definition of simple pendulum? Please start writing. Please start writing, my dear kids, because notes is very important. We have to write notes. Come on, start. Simple pendulum. Everybody define பண்ணலாம். யாராச்சும் help பண்ணுங்க பார்க்கலாம். எனக்கு Arjun, can you please help me how to define simple pendulum? Yes, a point mass suspended by means of point mass suspended by means of சொல்லுக்கண்ணே
thread or a string, sir.
suspended by means of massless string. We want to tell that the string should not have any mass. That's what she referred, thin thread, thin string. That's what, like this, thin string. Yes, you can see. Yes. Okay, come on, start writing. A point mass suspended by means of சொல்லுக்கண்ணா suspended by means of massless thread. Massless thread. A point mass suspended by means of massless thread is called, come on.
Sir, massless thread from an infinite rigid support.
No, suspended by means of, by using that. Of course, what she is telling is this support should be infinite. That is not compulsory. Support should be of infinite mass. That may not be compulsory. Even an ordinary metal stand would do. அது இன்ஃபினிட்டாக இருக்கணும்னு முக்கியம் இல்லை கண்ணே. என்ன புக்கில் அப்படி கொடுத்துருக்காங்களே, any book you have seen that, not necessary. That's not compulsory, right? Come on, start writing.
Okay,
A point mass suspended by means of massless thread is called simple pendulum. It's called simple pendulum. So a point mass suspended by means of massless thread. Suspended is very clear. Suspended from somewhere, maybe ceiling, maybe some stand, doesn't matter. Suspended by means of massless thread is called simple pendulum. It's called simple pendulum. I think it's right time we can go for derivation of simple pendulum. Yes, Kanna. Shall we go ahead? Yes. Please start drawing at least half a page diagram, because we want to pack a lot of information inside this. Yes, you can start. Bob, diagram is clearly visible, or should I put it on focus? Is this better? I think this is better, right? Yes, this is better, I think. Board is clearly visible, my dear kids?
Yes, sir.
Yes. Now, the simple pendulum now oscillates like this. What I do, it's in equilibrium position. I pull it up to this and leave it. It comes, right? I pull the simple pendulum up to this and just I leave it. So it starts oscillating. Sariya? Right. Now, the simple pendulum starts oscillating. எப்படி பண்ணலாம் சொல்லுங்க பார்க்கலாம். It has to start oscillating. Look at me. Yes. Yes. Walk on. Draw a curvature. I'm planning for a neat curvature, but you can draw by using campus or something like that. You'll get. Yes. Now this is a path in which it's going to oscillate. Circle. It's a part of circle, no doubt. It's a part of circle. Or simple pendulum oscillate avuduna, it's a part of circle, right? It's a part of circle, right? Now, this is the deviated position of the simple pendulum. This is theta. Come on, my dear kids. Here I want to begin at the point A. Can you identify various forces on the bob at the point A. Come on, this is point P. Suppose this is a point.
Gravitational force and tensional force.
Beautiful, Kanna. Beautiful, beautiful. This is what? Come on, help me. This is what? This is what?
Gravitational force.
mg. Then come on. This is what?
Tensional force.
Tensional force. Now I have a question for you. Out of this T and mg, which is greater?
mg.
Saratak says mg is greater. What about
Both are same. Since the bob is at rest, we can say both are equal.
so bob is at rest, therefore they are equal, right? Ashwini says. Okay. If the bob is not in rest, if the bob is not at rest, then what's your answer? If the bob is not at rest, what's your answer?
Sir, I guess it's the same right angle.
It is?
The tensional force and gravitational force both will be equal.
No. Sorry.
The tension will be greater.
Tensional force will be greater.
Arjun says tension will be greater, and one more child also says tension will be greater. Which will be greater? Tension is greater. Okay, good.
Restoring force on the same answer.
No, restoring force varla kanna. Inga restoring force kadayadu. At the point A, there is no restoring force. At the point A, it's a mean position. Let us call it as mean position. Right?
Okay, sir.
Mean position. There is no restoring force. There is no restoring force in this. Let me complete this also. Good, Kanai. Excellent, Kanai. Your answer is right. Probably. We'll check it. Sure, your answer is right. Now, here is mg. Look at. Here is mg. This is tension. This is tension. Right? Now tell me, yes, mg tension. Come on. Now, this mg can be split, cut into how many parts? This
Components.
component. Yes, I am doing that. How much is this?
mg cos theta.
The mg cos theta. How much is this?
mg sin theta.
Right, that's right. Go ahead. It is at the point P, suppose. It is at the point P, suppose. Any of you clearly understand, all of you clearly understand where the mg has come, where the tension has come, how we are splitting it? Any doubt anywhere? Anyone has got any doubt?
No, sir.
Vishnu, any doubt, Kanna? Vishnu Vijay, Vishnu Vikas? No doubt. I have clearly drawn. You should also draw clearly like that. If you are not getting clear diagram, score it out, draw a new diagram. Don't worry, just don't worry. The diagram should be perfect.
First class also.
இல்லைக்கா ஏற்கனவே ஒரு கிளாஸ் முடிச்சிட்டோமா, இன்ட்ரோடக்ஷன் முடிச்சிட்டோம். Now anyone please help me. At the point P, out of T and mg cos theta, which is greater? Already you gave me a correct answer. At the point P, out of T and mg cos theta, which is greater, they are equal or T is greater or mg cos theta is greater?
Equal.
They are equal, right? They are equal. Here at the point A, this is at the point P, this is the point A. At point A, T and mg, which is greater?
P.
T is greater. At the point P, they are equal.
Both are equal.
Okay. Now I take you to extreme position. This is the extreme position. What do you mean by extreme position? Where the body is going to take? Where the body is extreme. Means the body is going to take turn. இங்க என்ன பண்ண போகுது? Body இப்படி போயிட்டு இப்படி திரும்பி வர போகுது. It's going to take turn. Clear now? It's going to take turn. It's going to take turn here, right? It's a turning point, extreme position. It's an extreme position. Extreme position என்ன நடக்க போகுது? This is mg. You have to update your diagram properly. You have to update your diagram properly. This is also extreme position, extreme. I hope everyone has completed the diagram clearly. Shall I go ahead? Shall I go ahead, my dear kids?
Yes, sir.
But I am not getting answer online. From Zoom, I am not getting answer. Here in the classroom, kids are saying okay.
Sir, actually at the P point, the string is at rest or it's moving, sir?
That I will explain, don't worry. I will explain. Right? I will explain. Yes. Come on. So, this is a simple pendulum which is oscillating like this. Come on, it's oscillating like this. So, when you look at the extreme position, anyone please help me. At the extreme position, what's the speed of the simple pendulum? What? 0, because it's taking turn. It's taking turn. So, it's very clear. This extreme position, velocity v is equal to 0. This extreme position, again velocity v is equal to 0. No doubt about it. No doubt about it. Our body இப்படி போயிட்டு இருக்குன்னா it's taking turn. அப்படின்னா என்ன அர்த்தம்? டர்னிங் எடுக்கிற இடத்துல அதனோட ஸ்பீட் என்ன தான் இருக்கும்? 0 தான் இருக்கும். இப்படி பாடி தூக்கி போட்டா it is taking turn. At the topmost point, what is the velocity? 0. அப்போ டர்ன் எடுக்கிற இடத்துல நிச்சயமா velocity 0 தான் இருக்கும். சந்தேகமே கிடையாது. Right? So it's very clear case. come to the bottommost point. Bottommost point la kandipa velocity maximum irukka pogudhu, no doubt about it. Now I am not going to take extreme, I am not going to take mean, I am going to take theta position. Point P is my interest, time being, point P is my interest. Now the simple question arises, when the simple pendulum oscillates like this, it is a part of, the bob is tracing a part of,
Parabola.
it is tracing a part of circular motion. Is it not clear? It's a part of circle or not? Yes. This is what we are discussing about. See, this is what we are discussing about now. It's a part of circle. So, in other words, the bob is moving in circular path. The bob is moving in a circular path, simple. Not complete circle, but a part of circle. For any particle to move in circular path, in physics, it needs dash. What is a dash? Yes, necessary centripetal force should be there. Who is going to give you necessary centripetal force? Tension has to give. Tension has to give. But some fellow is saying, no, I will not give, I will oppose you. Who is that? mg cos theta. Of course, mg cos theta. Apo, tension wants to help centripetal force. mg cos theta says no. mg cos theta is no factor. Apo, who is the winner, who is the loser? Yes, tension must be a winner, mg cos theta must be the loser. Then only the show can go on. Then only the oscillations can go on. Oscillations point it is traveling in circle. If it is going in circle, there is centripetal force. Definitely, all the position tension alone should win. There is no other go, but for extreme positions. So in all the situations, tension is greater than mg cos theta or maybe mg, no problem. But tension must be the winner. Appodan show nadakkum. Illa sir, by chance mg cos theta has become slightly more than tension. Na enna neenga solla varinga nool cut aichi bob kele vada podunu artham. If somebody claims, sir, my mg cos theta is slightly more than tension, appadina enna artham na? What is the physical meaning? Nool edo vidathila cut aichi, the thread was weak, it got cut, the ball is going to fall down artham. Finished. Purida unake? Apo, which should be greater? Come on. Tension must be greater. Now, for the time being at +1 level, we always assume the angular displacement theta is very small. Now, in diagram, 30-35 degree I oscillate pannirken. Oscillate panna you should at the maximum you can oscillate only by 10 degree. Ana neenga school la experiment பண்ணும்போது என்ன பண்றீங்க அந்த லேப்ல எவ்வளவு தூரம் இருக்கோ அவ்வளவு தூரம் இப்படி இழுத்துறீங்க அப்படி விட கூடாது அப்படி பண்ண கூடாது that's not correct because we are going to assume sin theta is equal to theta, which is true only in the case of small value of theta, only for the small values of theta. Apo theta must be small, right? Come on, start writing. Consider a simple pendulum bob. Of mass m, suspended by using a thin thread, of length say L. Look at the board. Of length L. Let theta be the small angular displacement of the thread. Let theta be the small angular displacement of the thread that we consider. Small angular displacement of the thread that we consider. Let theta be the small angular displacement of the thread that we consider. Right then, that we consider. Yes. So at theta, mg sin theta, the component of force, the component of force, mg sin theta provides what? Can any of you guess?
Necessary centrifugal action.
Restoring force.
Beautiful. Restoring force. Restoring force. அதான் பிடிச்சி இழுக்குது. See, it is pulling you. It's pulling you, right? Necessary restoring force. Necessary restoring force. Necessary restoring force. Therefore, F is equal to net restoring.
So,
சொல்லுங்க.
sir, அப்போ நான் ஃபர்ஸ்ட் கேட்டப்போ ரெஸ்டோரிங் ஃபோர்ஸ் சொன்ன ஃபேக்டர் நான் சொன்னது கரெக்ட்டா சார்?
இல்லை கண்ணா, அது இங்கே இருக்குது. இது நீ கேட்டது நாம டிஸ்கஸ் பண்ணது இந்த இடம். தேர் 90 டிகிரி. இட்ஸ் நத்திங் டு டூ வித் ஈச் அதர். புரியுதா? அது சென்ட்ரிபிட்டல் ஃபோர்ஸுங்கிறது வேறு, ரெஸ்டோரிங் ஃபோர்ஸுங்கிறது வேறு, என்டையர்லி டிஃப்ரெண்ட். சரியா? ரைட், அது வருவேன். நான் இதை முடிச்சுட்டு அதுக்கு வரேன். ஐ வில் கம் டு தட். நெட் ஃபோர்ஸ் ரெஸ்டோரிங். கமான் கண்ணா, யாராச்சும் எனக்கு ஹெல்ப் பண்ணுங்க. வாட்ஸ் நெட் ரெஸ்டோரிங் ஃபோர்ஸ்? கமான், யாராச்சும் எனக்கு ஹெல்ப் பண்ணுங்க. Who is going to give restoring force? mg sin theta. mg sin theta, of course. For small theta, sin theta will be approximately taken as tan theta. அது sin theta வந்தாலும் tan theta வந்தாலும் நம்ம theta ன்னா எடுத்துப்போம். What's net force? ma is equal to mg multiplied with theta. Now once you put vector, you have to put minus here. Sorry, well, vector and update because it's in terms of theta now. Next step la potukalam better. Look at here. This distance is what? Yaaracham help pannunga. From main position, the bomb has displaced this much. What is this red color? What I marked? What is this? What do you want to call it? No. No. I want to click. One second. Let me. Simple pen la vandu bob vandu ipdi irukku. See, this is a bob. Idu varunga. I am displacing it like this. I am leaving it. From here, the bob has gone here. What is this? In physics language, the body is here. Now it has gone there. What is that?
Displacement.
Displacement. Beautiful. That's displacement. Theta. Y. This is y vector. Put arrow mark. Ipdi pochu. Y vector. Right? Y vector. Right? So, come on. You please go back and check. Theta enadhu? Yara solunga, what is theta? Please check your notebook and tell me.
Y by L, sir.
No. What is theta you have written? Please check. Already you have written on notebook. Please check it and tell me. Few lines back only I dictated. What is angular displacement?
Angular displacement.
I want that. Angular displacement. Theta is the angular displacement. Y is
Displacement.
linear displacement. That's what is displacement. That's what is displacement. So, one can measure y in meter, theta in radian. புரியுதா? Make it clear. Concept வந்து crystal clear புரிஞ்சிட்டு வாங்க. புரியுதா? சும்மா ஏதோ அரைகுறையா புரிஞ்சிட்டு அப்படிலாம் எழுதாது. புரியுதா? So, let us start now. Let us continue now. Let y be the linear displacement when the angular displacement is theta. 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 So, theta is the angular displacement, y is the linear displacement. What unit you measure y? Meter. What unit you measure theta? Radian. Make it clear. Yes. Now, This is sector of a circle. Look at this is sector of a circle. Look at, I am shading it. This is sector of a circle. In a sector of the circle, go back to 9th standard, 8th standard. What is theta?
Arc divided by radius.
Yes, theta is given by arc by radius. You know very well. Now who is arc? Look at there our diagram, red color.
Linear displacement.
Y.
Yes, y by what is radius?
Y by L.
L. Beautiful, that's right. Equation number 2, equation number 1. Now you substitute 2 in 1. Now you substitute 2 in 1. So A is equal to minus G times Y by L. Now you can very well put vector. Now you can very well put vector. இதுக்கு முன்னாடி நீ போட முடியாது. Before that you cannot do because theta is also vector, no doubt, but there is a pseudo vector, so I don't want to confuse you. Now you can put vector. I will explain that, don't worry. A is equal to minus G by L times Y vector. Copy it, my dear kids. Copy it. Completed up to 3.
Yes, sir.
Equation 3 shows. Equation 3 shows. யாராவது சொல்லுங்க பார்க்கலாம் என்ன கண்டுபிடிச்சீங்க equation 3 ல இருந்து? Acceleration is directly proportional to
Acceleration is directly proportional to
Acceleration.
the
displacement. Yes. So please write down. From equation 3, acceleration is directly proportional to displacement. Acceleration is directly proportional to displacement. And they are opposite in direction. And they are opposite in direction. Correct ah paru? Rendu perum opposite dana check panni. Of course, displacement sonna podum, not a problem. Acceleration is directly proportional to displacement. Adu linear irundhalum angular irundhalum okay da. Displacement, and they are in opposite direction. They are in opposite direction. எப்படி opposite பாருங்க, இங்க பாருங்க. This is your A, look at. This is your A. இதான் பிடிச்சி இப்படி இருக்குது. Look at. This is Y. அப்போ displacement increases like this, whereas acceleration increases like this. புரிஞ்சுதா இல்லையா? They are opposite each other. Very clear. Here both of them are opposite. No doubt about it. Yes. Therefore, என்ன சொல்ல போறேன் இவ்வளவு சொல்லிட்டேன். Therefore, simple pendulum. Come on, யாரோ fill up பண்ணுங்க சென்டர்ல. Therefore, simple pendulum come on kanna executes oscillates ஏன் கண்ணா அமைதியா இருக்கீங்க? Yes, with simple harmonic motion, or execute simple harmonic motion, or oscillates with SHM, whatever you call. Yes, execute simple harmonic motion or oscillates with simple harmonic motion. What do you mean by that? Simple harmonic motion last class enna kuduthirukkom paru, A is equal to, please check that. Therefore, A is equal to, please check last class notes and tell me, minus omega square times y. Equation number 2. Sorry, equation number 4. Now,
So simple harmonic motion.
that is last class kanna introduction. Simple harmonic motion. Yes. Now 3 and 4 are equal. Look at 3 and 4 are equal. Look at 3 equal to 4. Come on, 3 equal to 4. So what is your omega square?
F by L.
G by L.
E by L.
Yes. So omega which is nothing but 2 pi by T is what is omega, is nothing but square root of G by L. So T is equal to 2 pi into square root of L by G. Equation number 5. So we got time period, T is equal to 2 pi into square root of L by G. Then what's frequency? Then what is frequency? Yes, frequency nu is equal to 1 by T equal to 1 by 2 pi 1 by 2 pi into square root of G by L, 1 by 2 pi, right? 1 by 2 pi into square root of G by L. So equation number 6. Equation number 6. Is it clear? Idhuvaraikku narthandile edavadu doubt irukka kanna? Idhuvaraikku nama solli kodutha edavadu doubt irukka? Any doubt you have till now? Yes. It's good. Most of the students are attending on Zoom. That's good. Parvale. Today January 26, in spite of holiday, most kids have come. Good, good, good. But நிறைய பேர் வரல, அது வேற 50% attendance தான் இருக்கு. But what I mean to say, 50% itself good. I hope each one of you have drawn at least half a page NEET diagram like this. Am I right? Shall I take it like that?
Yes, sir.
Good, good, good. Muthu, Rahul, drawn करना है. Mridula, you have drawn NEET diagram.
Yes, sir.
Yes. I am not getting answer from Rahul and Muthuram.
Yes, sir.
Good, good, Kanna. Good. Shall I take you further? Polama further. Next step, Polama. At P, that is theta is the angular displacement and y is the linear displacement. T minus mg cos theta gives the necessary centripetal force. The necessary centripetal force. Necessary centripetal force. Necessary centripetal force. Yes, चलो पकड़ा T minus mg cos theta. यार कने centripetal force formula कोड कर दे. यार अच्छा कोड करना please. Anyone please help me? Anyone?
B squared by
B square by
L. Beautiful. some continuous number you give me, equation number, maybe already we gave already 6 I remember. I think shall I give you 7 now? Yes. So, at mean position, what's the value of theta? Any of you help me? At mean position, what's the value of theta? Look at the diagram and tell me. 0. What this equation number 7 will become? Yaro help pannunga enakku. Anyone help me? What will happen to the equation number 7?
P minus mg square by L.
Is equal to mv square by L. Equation number 8. Right. At extreme position, யாராச்சும் ஹெல்ப் பண்ண ஆமாம் இங்கே பாரு இது வந்து இப்படி சுற்றிட்டு வந்ததுன்னா இங்கே இருக்குல்ல டீட்டா இங்கே பாரு போர்டு பாரு டீட்டா தானே இது இப்போ எவ்வளோ டீட்டா அதான் மீன் பொசிஷன் வேணா ஏன்னு வேணா போட்டுக்கோ அட் ஏ ஓகே மீன் பொசிஷன் தான் கரெக்ட் தான் ரைட் at extreme position means theta becomes theta maximum, y becomes amplitude. What is amplitude? What do you mean by amplitude in physics?
Height of the wave.
Maximum displacement is called amplitude. அப்போ இங்க பாரு this is y increasing the maximum displacement is what is called amplitude. வேணுங்க மார்க் பண்ணிக்கோங்க உங்களுக்கு நல்லா புரியுங்க மார்க் பண்ணிக்கோங்க ஒன்றும் பிரச்சனை and the diagram itself you mark it. This is what is called A, the amplitude, maximum displacement. இதுதான் A. This is what is A, the maximum displacement. அப்போ y is expected to be always less than A. ஆமாம் இதில் ஒன்றும் சந்தேகம் கிடையாது. Only in the extreme position they are equal. Come on. Y becomes A. At the extreme position here at this point y equal to A. Even at this point y equal to A. Of course minus, that's a different story, right? Yes. இப்போ யாராச்சும் எனக்கு equation number 7 சொல்லுங்க என்னாவது பார்க்கலாம். Equation number 7, what will happen to equation number 7? யாராச்சும் எனக்கு ஹெல்ப் பண்ணுங்க பார்க்கலாம். T minus, come on, mg cos theta maximum equal to சொல்லுப்பா. I am waiting for your beautiful answer. Come. 0. Good. 0. ஏன்னா velocity is 0. Just now already explained you. புரியுதா? Extreme position velocity is 0. அப்போ இது 0 ஆயிரும். So this is the point what you are telling me. T is equal to mg cos theta max is only at this point called, let's call it as equation number 9. I hope you understood to some extent. ஒரு ஓரளவுக்கு லேசா புரிஞ்சிருக்கும்னு நினைக்கிறேன். Anyway, I'll show you here. இப்போ பாருங்க, I'm pulling it to the best of my level. Say 10 cm, 20 cm pull பண்ணி விட்டுட்டேன். Oscillate ஆயிட்டு இருக்கு. This extreme position is what? At the extreme position, what happens to speed of this pendulum? 0. So, where is the speed of the pendulum is maximum? At mean position, absolutely no doubt. ஏன்னா இங்க மேல போகும்போது its potential energy. It is increasing kinetic energy. It becomes kinetic energy. புரியுதுல? It is increasing. Clear now? So it becomes like that. Right. It goes. Shall we go ahead? T minus mg is equal to mv square by L. Copied. ஏதாவது doubt இருக்காது வரைக்கும்? Till now you have any doubt? Now we can go for factors.
The equation, the velocity velocity 0 மட்டும் மறுபடியும் சொல்றீங்க. சரி, அந்த equation 0 மட்டும் மறுபடியும் சொல்றீங்க சார்.
அதாங்கண்ணா, because see this term became 0, therefore right hand side entirely becomes 0. இந்த 0 தான் நமக்கு போட்டிருக்கோம். So we know that at the extreme position here and here the pendulum is taking turn, means the velocity is 0, means the velocity is 0. அதான் நம்ம சொல்றோம். That's what is the velocity 0. Is it not clear? T
அப்போ t is equal to mg cos theta அப்போ 0 ன்னு சொல்ல முடியாதுல?
அப்போ சொல்ல முடியாது. எங்க இந்த ஒரு இடத்துல மட்டும் தான் ஈக்குவல், வேற எங்கேயும் ஈக்குவல் கிடையாது. Try to understand. இந்த t is equal to mg cos theta is wrong. Cos theta max is right. அப்போ this t and this mg cos theta are equal only at the extreme positions, not anywhere. Please take note. Is it not clear?
Yes sir, understood.
இந்த இடத்துல t is greater than mg cos theta. Here t is greater than mg cos theta. Even here t is greater than mg cos theta. Only at the extreme positions t and mg cos theta max are equal. Is it not clear?
Clear sir.
Good Kanna. Good. Take note. Take note. Good question. Take note. நீங்கள் டவுட் அது மாதிரி கேட்டால் தான், சின்ன சின்ன டவுட் கேட்டால் தான் நல்லா புரியும். குட். Now, factors affecting time period of simple pendulum. Factors affecting time period of simple pendulum. Factors affecting time period of simple pendulum. Number 1, amplitude. Amplitude A. அதாவது amplitude என்ன அர்த்தம் பாரு, கவனிச்சு புரிஞ்சுக்கோ. Try to understand. இது ஒரு சிம்பிள் பென்ல என் கையில் கொடுத்துருக்காங்க. First I displace it by slightly 10 centimeter. Next time I displace it to 30 centimeter. Now will there be change in time period is a question. Look at my formula of time period. T is equal to 2 pi into square root of L by G. There is no amplitude in it. This is amplitude. Amplitude. There is no amplitude in the formula. Means it does not depend on amplitude. However, amplitude play a small role in the case of large oscillations that we don't consider. நம்மளை பொறுத்த வரைக்கும் as far as plus 1 syllabus IIT syllabus is considered, we consider only small oscillations. What do you mean by small oscillations? இப்படி பெண்டலம் இருக்குதுன்னா இல்லை வெறும் இப்படி விடக்கூடாது. Sin theta should be small, less than 10 degree let us say, less than 10 degree let us say. So அதனால for இப்போ நம்ம எப்படி எழுத போகிறோம் சென்டென்ஸ்னா time period does not depend on amplitude தான் தப்புது. ஏன்னா at some point of time it will become depend. If you have a large amplitude it depends. அப்போ நம்ம எப்படி சென்டென்ஸ் ஆரம்பிக்கணும்னா for small oscillations time period does not depend on amplitude. Come on. For small oscillations the time period does not depend on amplitude. For small oscillations time period does not depend on amplitude. For small oscillations time period does not depend on amplitude. Point number 2. Point number 2. For small oscillations time period does not depend on amplitude. Right? Point number 2. சொல்லுங்க வேற என்ன depend on சொல்லலாம்? Mass of the bob. M. Again look at the formula. Is there any M rule? No. Therefore, clearly, time period absolutely does not depend on mass. At least amplitude is some small oscillation or condition.
The factors time period மட்டும் தான்.
Sorry?
The factors affecting time period.
Time period தான் சொல்லிட்டு இருக்கோம். So, time period does not depend on mass of the bob. Mass of the bob. ஏன்னா mg கிடையாது, m கிடையாது formulaவில். So, time period again does not depend on mass of the bob. Number 3, length
Length of the string.
of the pendulum. of course string, length of the pendulum L. நமக்கு எல்லாருக்கும் தெரியும் T is directly proportional to square root of L. கிராஃப் போடலாமா? யாராச்சும் கிராஃப் போட்டு எனக்கு சொல்லுங்க பார்க்கலாம் எப்படி போடலாம்? கமான், இதுக்கு ஒரு கிராஃப் போட்டால் எப்படி பார்க்கும்? ஒரு கிராஃப் ட்ரை பண்ணலாமா? சொல்லுங்க பார்க்கலாம். இது T, இது வந்து L. எப்படி இருக்கும் சொல்லு பார்க்கலாம். இல்லை ஃபர்ஸ்ட் let us begin with T square L, உங்களுக்கு ஈஸியாக இருக்கும். T square L, T square and L are, look at T square and L are, என்னப்பா அப்படி யோசிக்கிறீங்க? Yes, T is directly proportional to square root of L. T square is directly proportional to L. You are right. So a straight line, I concluded. Next I wanted to go ahead with T and L. யாராச்சும் ஐடியா சொல்லுங்க எப்படி இருக்கும்னு ஒரு கெஸ் பண்ணுங்க பார்க்கலாம். T and L. இல்லை, இது T square Lக்கு இது. இதுக்கு எப்படி இருக்கும் ஷேப்னு கேட்குறேன். What will be the shape of the graph? I am asking you. Same. What is this? What do you mean by us? Good.
Its slope will be greater.
எப்படி இருக்கும்? This will be the graph. Check it. உனக்கு புரியலனா try பண்ணி பாரு. If you don't understand, I will explain my graph. If you don't understand my graph, I will explain. Don't worry.
TL graph புரியுது சார்.
ஆமாங்க, TL தாமா போட்டிருக்கேன்.
இல்ல சார், எனக்கு அது மட்டும் புரியல.
புரியல. Okay, I will explain. Let us wait for others. Anyone understood the graph clearly? Not very clear.
So ஒரு எக்ஸ்டென்ட் வரைக்கும் இன்க்ரீஸ் ஆகாதுமா கான்ஸ்டன்ட்.
அப்படிலாம் கிடையாது. அது இன்க்ரீஸ் ஆகிட்டே தான் இருக்கும். 1 1 2 2, right? This is T square, so it will become 4. இது 2 னா இது 4 ஆகும். Am I right? Proportional, of course நான் ஈக்குவல்னு எடுத்துக்கிறேன். ஈஸினஸ்க்காக ஈக்குவல்னு எடுத்துக்கிறேன். I take it as equal where constant k equal to 1 so that you can better understand the graph. எப்பவுமே கிராஃப் புரியலன்னா நம்ம என்ன பண்ணணும்? கான்ஸ்டன்ட் எடுத்துடணும். இப்போது T square is proportional to L னுக்குது. You have to put one constant. Take this constant as 1. You will better understand the graph. ஈஸியாக இருக்கும் கிராஃப் புரியறதுக்கு. சரியா? இப்போ சொல்லி பார்க்கலாம். Tக்கு என்ன வேல்யூ போட்டால் உனக்கு இங்கே 2 Lக்கு 2 போட்டால் Lக்கு 2 போடுற. அப்போ T ஸ்கொயருக்கு என்ன பண்ணும்? இங்கே என்ன பண்ணும்? Yes, 4. Correct. So the T square is equal to 1 into L. Right? Am I doing correctly? Correct. இது வந்து square L. Both of them should be directly proportional. So 1 1 2 2 3 3 4 4 எடுத்துக்கலாம். 4 4 கரெக்ட் தானே? எனி டவுட்? 4 வரணுங்க. அதாங்க நான் மிஸ்டேக் பண்ணிட்டேன். யூ ஆர் ரைட் 4. இந்த இடத்துல எவ்வளோ வரணும்? ஒரு 3ன்னு வச்சுக்கோங்களேன். அப்போ எவ்வளோ ஒரு 9. இந்த இடத்துலையும் 9 வரணும். தென் ஒன்லி இட்ஸ் டைரக்ட்லி ப்ரொபோஷனல். தென் ஒன்லி இட்ஸ் கால் டைரக்ட்லி ப்ரொபோஷனல். புரியுதா இல்லையா? எஸ். நவ் டெல் மீ. நவ் ஸ்டார்ட் T. 1 1. Next.
Sir, ரெண்டுமே directly proportionalன்றதுனால அதோட வேல்யூ சேம் ஆகுது சார்.
அதாங்க நான் இவ்வளோ நேரம் சொன்னேம்மா. T square is directly proportional to L. You make it equal. What will you advise? What you will advise me to put here? Come on.
ஒரு proportional.
அந்த கான்ஸ்டன்ட் நான் 1ன்னு சொல்கிறேன். வாட்ஸ் ராங் இன் தட்?
Okay sir.
அப்படி போட்டால் தான் உங்களுக்கு ஈஸியாக இருக்கும் கிராஃப்னு சொல்கிறேன். தட்ஸ் ஹவ் யூ ஃபைண்ட் த கிராஃப் டு பி ஈஸி. கம் ஆன். இப்போ அப்படியே அந்த கிராஃப் கன்வெர்ட் பண்ணுங்க. வாட் ஐ எம் ட்ரைங் டு டூ இஸ் ஐ ட்ரை டு எக்ஸ்பிளைன் யூ ஹவு டு ட்ரா த கிராஃப். கம் ஆன். 1 1. இப்போ வாட்ஸ் வேல்யூ ஆஃப் T? இங்கே வந்து T எடுத்துக்கிட்டேன், இங்கே L எடுத்துக்கிட்டேன். கரெக்ட் தானே? தட்ஸ் வாட் ஐ எம் ட்ரைங் டு ட்ரா. கம் ஆன். T. If T square is 4, what's the value of T? If T square is 4, what's the value of T? 2. So 2, but this is 4. So that graph becomes ulta. What you said is correct. நீங்கள் என்ன சொன்னீங்க? I think here in my classroom here This boy says it is parabola you called. Correct, that's perfect, you are right. It's parabolic curve. Now it's parabolic curve. 1, 2, 1, 4. Is it not clear now, my dear kids? No, never. It will not become, that never become flat. Flat or e power x. No, flat porna e power x. Flat porna e power x. Good, can I please take graph? Just one more point. Time period depend on, I think, fourth factor, I believe. Acceleration due to gravity. G. What's the acceleration due to gravity? G factor. Come on. T is equal to the Adalla right. T depends on what? I am asking. T depends on. Excellent. That's right, Kanna. Inversely proportional to G. Graph again I am starting my graph. This is G value. It is T square value. T square and G. What will happen? T square and G. What will happen? T square. Directly proportional, inversely proportional. What will happen? Come on.
Downward slope also.
That's right. You are right, Kanna. You are right. Yes, downward slope. This is what is like PV diagram in your chemistry. Chemistry PV diagram, na thermodynamics PV diagram PV, pressure, volume. Boyle's law. Don't you know?
Yes, sir.
Yes, exactly same. PV diagram. One more straight line graph you can try. That you know very well how to manage that. One time T, one side T, inner side 1 by square root of G graph. Straight line, exactly. Come on.
I have a doubt.
Yes, Kanna, please.
G is constant and T.
Of course. I am coming to that. Wait for some time. Come on.
No, sir, the first.
Sir, I'm not understanding that P square and G
the
graph.
y-axis and G is x-axis.
Oh, that's your question. Okay. This is, if you have doubt, you can put G dash here. Don't call it as G. By calling G, she has got doubt that, sir, 9.8 is a constant, how come it's variable? That's what she is having doubt. We know, you please go back in our physics, laws of motion. If you are standing in a lift, accelerator, lift in your apartment, if the lift is accelerating up, what's your acceleration?
Okay.
What's your acceleration? No? G plus A, beautiful. If the same lift is accelerating down with acceleration A, what's your net acceleration? G minus A. You are jumping in a swimming pool from a launch pad, you are free fall, what's your acceleration?
mg.
0, don't you forgot, weightlessness.
A is equal to A.
Yes, weightlessness. G minus A, where A is equal to G, answer is 0. Upper swimming pool jump, that's how we feel excited. Excitement yeah. We experience zero gravity, weightlessness. That's weightlessness. Common man zero gravity. That's physics. வெயிட்லெஸ்னஸ்ன்னு சொல்கிறோம். சரியா? ரைட், கமான். ஐ ஹோப் இப்போ உனக்கு புரிஞ்சிருக்குங்கண்ணே. நீ கேட்கறது கரெக்ட் தான். நான் ஜீன் போட்டால் தப்பு தான். ஏன்னா 9.8 யூனிவர்சல் கான்ஸ்டன்ட். அதை போய் அட்லீஸ்ட் ஆன் த சர்ஃபேஸ் ஆஃப் தி எர்த் இட்ஸ் கான்ஸ்டன்ட். கரெக்ட் தாங்கண்ணே. யூ காட் இட் நவ்? யூ காட் இட் நவ்?
சார் அப்போ அது ஸ்விங் ஆகும்போது அதோட ஆக்சிலரேஷன் டிஃபரன்ஸா சார்?
Not at all, not at all. This graph talks about you do experiment in a static what you call lift, and then you are doing the carrying out the same experiment in an accelerated lift. Will the answer be same? Where can I?
Showing the gravity and the different positions of the baba, sir.
Connect different situation, not different position. என்ன நீங்க இப்படி கன்ஃபியூஸ் பண்ணிக்கிறீங்க? One second, let me explain. One second. First, I want to do the experiment in this room where the room is static. I got some answer where G I will substitute 9.8. Next time I carry out the same experiment in my apartment while my lift is moving up with an acceleration. While my lift is moving with an acceleration. அப்போ நான் G க்கு பதிலா என்ன சப்ஸ்டிட் பண்ணணும்? G plus A. அப்போ இது எனக்கு G, இது எனக்கு G plus A. அதுதான் G dash ன்னு சொல்றேன். Now my lift is going down. I am doing the same experiment. Now what is that? G minus A. இப்போ புரிஞ்சது at least. I am getting 3 points and I am completing my graph. Is it clear now at least?
Sir, G plus A தான்
Yes,
சார் முன்னாடி
yes,
வரும்.
sir.
ஏம்மா இப்படி தானே G இன்க்ரீஸ் ஆகுது?
Question was pertaining to the second graph.
இது எக்ஸ் வேல்யூ. நீ கிராஃபை பார்த்து கன்ஃபியூஸ் பண்ணாது. எஸ் 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 சொல்லுங்கண்ணா. எஸ் கம் ஆன்.
Sir, my question was pertaining to second graph.
Yes.
In the first graph, we are telling that G is dependent on T. Like T is dependent on G.
Absolutely.
But,
Absolutely, you are right.
sir, how are we writing 1 by root G dash in the...
எல்லாம் ஒன்று. It is same now. Look at here. Look at here. T is inversely proportional to square root of G. Look at. Square both side. T square is 1 by G. என்ன பிரச்சனை உங்களுக்கு சொல்லுங்க? Come on, what's your problem? What's your problem?
No, sir, my question is the position of T and G in the second graph.
அது எப்படி இருந்தால் என்னமா இருக்குது? டைரக்ட் யூ ஆர் பாதர். டசன்ட் மேட்டர். நான் அது கிளியராக ப்ரூஃப் பண்ணி தானே உங்களுக்கு போட்டிருக்கேன். வாட்ஸ் அ ப்ராப்ளம்? ஷீ வாண்ட்ஸ் T to be here, square root of 1 by square root of G dash to be here. Straight line வரும்போது this way or that way, it is after all straight line. You need not bother about it.
So I took it depending upon the dependent and the independent variable.
அது எப்படி வேணாலும் போட்டுக்கலாங்க. நாட் அ ப்ராப்ளம். இதில் டைம் பீரியட், கிராவிட்டி ரெண்டுமே எனிதிங் யூ கேன் கண்ட்ரோல் as a variable. That's your choice. There's nothing called dependent, independent, right? Only in the case of time we prefer to take time along x-axis in general. But here time is not that. This is time period. It's not time. So it's not running time. It's a time period. எப்படி வேணாலும் போட்டுக்கன்னா நோ ப்ராப்ளம். புரியல உனக்கு?
Yes, sir.
Yes.
Gravity
சார் ஃபர்ஸ்ட் டயகிராம் எப்படி சார் பெண்டுலமோட கம்பேர் பண்றது? எந்த பொசிஷன்ல எந்த மாதிரி சார் ஆக்சிலரேஷன் எடுக்கணும்?
ஐயோ மறுபடியும் நீ பொசிஷன் கேட்குறியே. See,
எந்த மாதிரி சிச்சுவேஷன்ல சார் நம்ம வந்து எந்த ஆக்சிலரேஷன் சார்?
இது வரைக்கண்ணே இப்போ this simple pendulum is oscillating in my room. What's the value of G? 9.8 fixed. So I have completed my graph. Look at here. I'll explain you. I completed my graph. I got T to be 2 seconds. Time period is 2 seconds. Of course, square வேணா போட்டுக்கோங்க. Square. What is this? 9.8. Next time what I do the same experiment while my lift is accelerating up. What's my gravity in my cabin? What is gravity in my cabin? Come on. G plus A. So now you substitute G plus A here. What will happen to your time period? Will increase or decrease? Come on. When it decrease. That's what I am doing. See, acceleration has increased, time period has decreased. புரியுதா இல்லையா? Clear now. Next.
அப்ப நம்ம இது பண்ணும்போது அந்த frame of reference வெளில வந்துரும் சார்.
நீங்க அங்க தான் பண்றீங்க. What's the problem? You are also accelerated A G plus A. Your pendulum also accelerated G plus A.
Sir,
அப்ப அந்த whole system ஓட equation மாறுது.
Exactly. It is always like that. Say for example, scientist in space ship in the outer space. Scientists go and stay there for 3 to 6 months, do some experiment, then they come back. What's the gravity that they experience inside the spaceship? You tell me. 0. They are experiencing 0 gravity. You know that very well. So, zero gravity is the situation inside the spaceship, whosoever the scientist, whatsoever the equipment. புரியுது இல்லையா? That's what I am calling it as frame. That's what you are calling as frame. I am calling it as cabin. எல்லாம் ஒன்று that makes no difference. Clear? Yes, come.
Gravity எடுத்துக்கிறதுனால like at poles and at equators நமக்கு
அதுக்கெல்லாம் நம்ம இன்னும் வரல. You are right. It will make a great difference. I will come. You are right. Is it clear, Kanna?
Yes, sir.
Yes. Now please go ahead. Fifth point. If the time period of pendulum t is equal to 2 seconds, if the time period of pendulum t is equal to 2 seconds, if the time period of pendulum t is equal to 2 seconds, it is called if the time period of pendulum t is equal to 2 seconds, it is called seconds pendulum. It is called seconds pendulum. It is called seconds pendulum. அது அவ்வளோதான், அது ஃபிசிக்ஸில் அப்படி தான் டெஃபினிஷன். That's why I am giving you separately. In physics, time period is 2 seconds. I'll explain. I'll try my best. So, t is equal to 2 is equal to 2 pi into square root of L by G. So, square root of L by G is equal to 1 by pi. G is equal to 9.8 if you substitute meter per second square. If you substitute, what you get is 1 by pi the whole square equal to L by G, squaring both sides. You know, all of you know what's the value of pi square. What's pi square, you know? Any of you know what's the value of pi square?
10.
Around 10, very, very close to 10. Cancel. What L value you get? Come on. So, in physics, you make it a point. Whenever length of the pendulum equal to 1 meter, time period is automatically 2 seconds. This concept is what is called seconds pendulum, shortcut, seconds pendulum. So, in a particular question in our class, school question paper or entrance question paper, a seconds pendulum oscillates in a lift. அப்படினு ஆரம்பிக்கிறாங்கன்னா என்ன அர்த்தம்னா its length is 1 meter னு அர்த்தம். Clear now? Its length is 1 meter. It is a meaning, its ultimate meaning. Or its time period is 2 seconds அப்படிங்கிறது அர்த்தம். Seconds pendulum 1 second போட்டு கூடாது. புரியுதா? This is a fundamental idea in physics. Okay, it's a convention. It's a convention in physics. Please go ahead. Convention. Next point, point number 6, I believe. Your point, what you said, valid point. What is it? Yes, this is the Earth, the globe, equator, poles. Younger acceleration due to gravity is maximum. Come on. Where the acceleration due to gravity is maximum? Come on. எங்க அதிகமா இருக்கும் gravity 9.8 poles it is no equator is less poles the gravity is more so gravity more means what will happen to time period?
It
It will decrease.
Less.
Therefore, please take note, point number, next point maybe 5th, 6th or 7th point, whatever may be. When you move from equator to poles, when we move from equator to poles of the earth, maybe north, maybe south, poles of the earth, acceleration due to gravity increases, time period of simple pendulum decreases. Acceleration due to gravity increases, time period decreases. Is it okay? Clear up புரிஞ்சதா கண்ணா இது வரைக்கும் கொடுத்தது சொல்லி கொடுத்தது simple pendulum you understood really?
Yes, sir.
Next போலாமா?
Yes, sir.
Yes. In ஒரு 5 to maximum 5 to 10 minutes will wind up, maximum 5 minutes will wind up. Now I want to take a simple pendulum like this. It's going to oscillate like this. It's going to oscillate like this, right? It's going to oscillate like this. It is going to oscillate like this. Yes, it starts at the time t is equal to 0. In the sense, நான் என்ன சொல்றேன்னா simple pendulum எங்கிருந்து ஆரம்பிச்சதுன்னா எங்கிருந்து ஆரம்பிச்சது? It started from
D is equal to X is equal to
mean position, y is equal to 0 position. At t is equal to 0, y equal to 0. இதனோட அர்த்தம் என்னன்னா கவனிக்கணும். பட் சிம்பிள் pendulum இப்படி ஆடிக்கிட்டு இருக்கு. நல்ல கவனி. இப்படி ஆடிக்கிட்டு இருக்கு. உன் கையில ஸ்டாப் வாட்ச் கொடுத்துட்டாங்க. நீ எப்போ ஸ்டாப் வாட்ச் ஆன் பண்ண போற? When you are going to start your stopwatch?
motion make.
The moment it comes to mean position. கவனமா அப்படி பார்த்துட்டே இருக்கணும். டப்புன்னு ஆன் பண்ணணும். எப்போ ஆன் பண்ணணும்? When the simple pendulum is at mean position. Is it not clear? What I am trying to say is clear, Rahul? Yes. So you have to start your stopwatch. Your time starts running when the simple pendulum is at mean position. புரியுதா இல்லையா? mean position. So நான் கிளியரா அங்க எழுதிறேன். t is equal to 0 at mean position. t is equal to 0 at mean position. t is equal to 0 at mean position. கான்செப்ட் புரிஞ்சுதா? ரைட். இப்போ இதுக்கு யாராச்சும் எனக்கு ஈக்குவேஷன் கொடுங்களேன். நம்ம லாஸ்ட் கிளாஸ் நடத்தணும் இல்லை, நிறைய ஈக்குவேஷன் நடத்தணும் இல்லை. இதுக்கு யாராவது ஈக்குவேஷன் அட்டாச் பண்ணி பார்க்கலாம். கமான் கமான் கமான்.
So the y is equal to
ஆமாம் ஆமாம் அதே தாங்கண்ணே சொல்லுப்பா.
sir the y is equal to omega a cos
எக்ஸாக்ட்லி யார் எனக்கு அட்டாச் பண்ணுறது ஈக்குவேஷன் ஃபார் திஸ்? கமான்
omega t plus f.
துவரகேஷ் எனக்கு ஆன்சர் சொல்லு. இதுக்கு ஒரு ஈக்குவேஷன் அட்டாச்மெண்ட் கொடு. இதுக்கு ஒரு ஈக்குவேஷன் கூட. இந்த ஃபர்ஸ்ட் கேஸ் நான் கொடுத்துருக்கேன். ஈக்குவேஷன் கொடுப்பா. கமான். இப்போ ஸ்லோலி ஐ எம் டேக்கிங் டு யூ டுவர்ட்ஸ் ஃபேஸை பற்றி ஃபேஸை நோக்கி கொண்டு போயிட்டு இருக்கவனே. கமான். சம்மன் ஆஸ்க் மீ ஃபேஸ். எஸ் கமான்.
Sir omega a cos epoch.
அதான் தட்ஸ் வாட் ஐ வாண்ட். அனிருத் எனக்கு ஒரு ஈக்குவேஷன் கொடுக்கண்ணே.
0
அனிருத் எனக்கு ஒரு ஈக்குவேஷன் கொடுப்பா. இதுக்கு
Sir,
But face
y is equal to, come on Kanna, you are right, you are my dear kid, come on
A sin omega.
a sin omega
A
t.
sin.
Yes, you are right, perfect. You are right Kanna, super. This is the equation for this. எப்படின்னு கண்டா அரே ஒன்றும் வேணாப்பா, கண்ணை முடிக்கும், டைமுக்கு 0 போடு இந்த இடத்துல. என்னாச்சு ஈக்குவேஷன்? 0. That's what I'm telling you. I am asking you to switch on the watch when the pendulum is at y is equal to 0. இதான் y equal to 0. இதான் y equal to a. இதான் y is equal to minus a. புரிஞ்சதா இல்லையா? இப்போ நான் எப்போ நான் switch on பண்ண சொன்னேன்? when y equal to 0. இதில் 0 போடு. Are you getting 0? Finished.
Sir, அப்போ a cos theta is
இந்த வர I'll come. Question number 2. Start. இப்போ தான் slowly I am taking you towards the phase and phase difference, that part. But not exactly that. Just I am trying to make you understand the concept. Later I will do that. Now, here time t is equal to 0. So, t is equal to 0 at extreme position. Time t is equal to 0 at extreme position. Time t is equal to 0 at extreme position. அப்போ watch எங்க ஆரம்பிக்கிறீங்க? At the time t is equal to 0, y should become a. யாராச்சும் எனக்கு ஐடியா சொல்லப்பா. Come on, your idea. Come on, tell me. சொல்லுமா?
so
theta must be 90 degrees.
Yes, theta must be. ஆனால் இங்கே பாருங்க, theta 90 இருக்கா பாரு. இங்கே theta 90 பாரு. Is it 90?
no sir, acute.
Yes, it's
Theta
acute.
was, sir.
But theta 90 நீங்கள் சொல்கிறீங்க. அப்போ theta நான் 90 போடணுமா, acute போடணுமா?
Omega into t should be 90.
Beautiful. That's a point. So, y is equal to a sin omega t plus 90 degree is the expected equation. இப்போ பாருங்க, நீங்க 0 போட்டு பாருங்க t க்கு. now இப்போ t is 0, என்ன நடக்குது பாருங்க.
0 sin 90
Now equal to 80.
You got it. No sir, I don't like this. Tell me something else. Yes, you can also y is equal to a cos omega t. என்ன பிரச்சனை? ஒரு பிரச்சனையும் கிடையாது, போட்டுக்கோ. ஃபைன். நீ சொன்னது your idea. அப்போ t 0 போட்டா என்ன வருது? y equal to a. Finished. இப்போ கொஸ்டின் என்னன்னா, கொஸ்டின் நம்பர் 1க்கும் கொஸ்டின் நம்பர் 2க்கும் what's the phase difference? 90 degree. Who is leading?
90 degrees.
Who is leading?
Cos.
Who is leading? Cos. Number 2 is leading with respect to number 1. ஏன்னா இதில் வெறும் ஒமேகா டி, இதில் ஒமேகா டி ப்ளஸ் 90. கிளியராக தெரியுது யார் முன்னாடி போகிறான்னு தெரியுது. யார் முன்னாடி போகிறா? 2 is going ahead. கான்செப்ட் லேசாக புரிய ஆரம்பிக்குதா? Take note of that. Take. எதுக்குன்னு ஒன்றும் இல்லைடா, நீங்கள் வந்து டீக்கு 0 போட்டால் கவனி, டீக்கு 0 சப்ஸ்டியூட் பண்ணால் சைன் இது 0 ஆகிடுச்சு, 90 இருக்குது மிச்சம். அப்போ சைன் 90 எவ்வளோ? சைன் 90 1 into a, அவ்வளோதான். that's our question. டீக்கு 0 போட்டால் a வரணும். அதாவது இங்கேருந்து ஆரம்பிக்கிறேன். இங்கே எவ்வளோ வேல்யூ? வாட்ஸ் y? a. அதுதான் கொஸ்டின். அதாவது இது எப்படின்னா, எனக்கு பாரு, இப்படி இது ஆடிக்கிட்டு இருக்கு. நீ எப்போ டைம் வாட்ச் ஆன் பண்ணுற, யாராவது எனக்கு ஹெல்ப் பண்ணு. when you are going to start the watch, இங்கே y equal to a இருக்கும்போது டப் ஆன். this is what is the case. புரியுது உனக்கு? so the moment you start, the amplitude is a. In the case the moment you start, displacement is 0. இங்கே the moment you start, the displacement is a. the moment you start, the displacement is 0. அவ்வளோதான் வித்தியாசம். புரியுதுல்ல?
Sir, can you explain how is omega a sin omega t plus 90? I didn't understand.
See, I want to achieve this in mathematics. So the condition given to me, at the time t is equal to 0, I should be at the a is equal to y position. So இங்க இருக்கணும் என்னோட
So
பெரிய.
that part I understood y is equal to a.
Yes. So let us make trial and error with our trigonometry. When you accept this equation, substitute t is equal to 0, what do you get? T equal to 0, substitute t is equal to 0, what do you get? Sin 90, what is sin 90?
Sir, how did the 90 degree come in, sir? I have that doubt.
That's what, I want to achieve this. It will take time, Kanna. Wait. It will take time. I got your point. Diagram shows acute angle. I am adding 90 degree. How it is, why it is. That's what you don't understand. Am I right?
Yes, sir.
Yes. I will explain. Wait. I will explain.
But the cos form I understood y is equal to a. I had the doubt in that sign.
Anything, your choice.
So like in the cos form I was able to understand how y is equal to n.
Yes. Simple. See, just you close your eyes. Put t equal to 0. What is cos 0?
That I understood, sir.
In
the sign expression.
I will explain. Wait. I will explain. Just now, right now I will explain. Don't worry. Just copy it. I will explain. Just yesterday's topic. I had to go back to yesterday's topic just to explain you. Yes, this is the case. If the particle starts from here at the time t is equal to 0 and goes head like this, or maybe going head like this, t equal to 0, right? Y projection now we will take y projection without any confusion. So my particle starts here. I want to have flashlight here. What's my shadow position for this particle? What's my shadow position for this? 0. Y equal to 0. This is the case 1 I explained you. My particle started here, t is equal to 0. This is the case 1 I explained you. Please check case 1. If t is equal to 0, y equal to 0, this is a case. Case 2, my particle starts from here and goes like this. So when my particle is here, what's the shadow length? Come on. Y is equal to a. You agree with me or not?
Yes, sir.
Yes. So I wish at the time t is equal to 0, my y should be equal to a. At the time t is equal to 0, my y should be equal to a. Y value should be equal to a. You understand the point? Y should be equal to a. Is it clear? Now the shadow is falling on this. A. So after 90 degree of travel, I have reached here. Is it not clear?
So first quadrant 90 minus theta.
Is 90 minus theta?
First quadrant.
What is 90 minus theta?
Yes, sir.
So here I start. I have traveled 90 degree. Now I have come here. What's my shadow now? Look at light. Look at my light. What is shadow now? 0. This is what is the second case. So if your particle starts from theta is equal to 0, this is theta is equal to 0 position. You get y is equal to a sin omega t. If your particle starts from 90 degree position, you get theta is equal to a sin, so a cos omega t or sin 90 plus theta. The particle starts from here, a sin omega t. The particle starts, Bob starts from here, a cos omega t or a sin omega t plus 90. It is not 90, doesn't matter. Okay, see, the pendulum has gone from here to here. Again it goes from, look at, this is the pendulum position. So don't call this as angle. Either angle, don't call this as angle. This what this Bob marks is not the angle. Angle is the angles covered by the circular, the body under circular motion. We treat shadow. Shadow will not cover 90 degree. You try to understand. This is shadow, Kanna. This is shadow. Come back. This is nothing but shadow of displacement. It's a displacement of the shadow, not the real displacement. Real displacement engarke circular path. Is it not clear?
Yes, sir.
Yes. You just work on it. Today I have given you some idea about phase, not exactly, just to have a thought process over it. So next class we will start with phase and phase difference and all, and then we will go for energy of simple harmonic oscillator, and then we also will go for energy of time period of spring in series parallel. All those things will complete. I think it's better to have everyday class from now. Is it okay? I already discussed with you. I wanted to next week probably I will have everyday class, but it's completely recorded in YouTube, and I will give you the playlist. If you are unable to attend on a particular day due to school exam or this or that, whatever may be the reason, you can watch on YouTube. Is it okay, Kanna? So that by next weekend we can complete the 100% syllabus.
Sir, Sunday class மட்டும் மார்னிங் இல்லாம அது மட்டும் டைம் மாத்த முடியுமா சார்?
எதுக்குன்னு?
சண்டே கிளாஸ் மட்டும்.
சண்டே கிளாஸ் எப்படி நான் ஐஐடி ஜேஇ தாங்க எடுப்பேன்.
ஆமா சார், சண்டே கிளாஸ் எனக்கு அட்டென்ட் பண்ணுவோம். அது வந்து மார்னிங் வந்து டியூஷன் மேத்ஸ் சார் வந்து காலையிலேயே மாத்திட்டாரு டைமிங்.
அது நம்ம டைம் எதுவுமே மாற்ற முடியாது கண்ணா. ஏன்னா இது முடிச்சுட்டு நிறைய குழந்தைங்கள்லாம் மேக்ஸுக்கு போகிறாங்க இல்லையா? இங்கே முடிச்சுட்டு அப்புறம் நிறைய குழந்தைங்க மேக்ஸ் டியூஷன் போகிறாங்க, ஐஐடி மேக்ஸ் டியூஷன் போகிறாங்க. ஸோ ஐ திங்க்
அது சார் டிஆர்எஸ் சார் வந்து அது காலையிலேயே மாத்திட்டாரு சார் 29th இந்த டைமிங்.
என்ன டைமு?
காலையில 7 to 10 தான் மாத்திட்டாரு சார் அவரு.
ஓஹோ, ஐ வில் செக் தட் கண்ணா. நான் அவர்கிட்ட பேசுகிறேன். இன்றைக்கி தான் அவர்கிட்ட பேசிகிட்டு இருந்தேன், உட்காந்து ஒரு மணி நேரம் பேசியிருந்தேன். அவர் சொல்லவே இல்லையே. நான் பார்க்குறேன், நான் பேசுகிறேன் அவர்கிட்ட, பார்த்துக்கலாம். வில் செக் தட் கண்ணா. ஓகே, பாய்.
Thank you sir.
Bye Kanna. Bye.
Thank you, sir.
Bye Kanna.
Thank you, sir.
Bye Kanna.
Thank you, sir.
Bye Kanna.
Thanks, sir.
Bye Kanna. Bye all of you. Bye.